time it's going. All right, that's looking good. Phone caught it. Excellent. Also, let's put this out on Twitter. So, happy Friday. Let's learn some Rust together. I need to log in on this computer so I can do this a little bit faster this time. But everything. Send that out. Go on to that Slack channel that I have for it. Let everybody else know too. There we go. All right, let's go check a look, see if the dashboard is up. Render not available. That's lovely. Not online. Let's try refreshing. All right, bitrate. That seemed low for a second, but now it is nice and steady, right where I want it. Live, but it can't preview the video. Let's bring this chat out. Make it dark mode. All right, bring you onto the left side. That's good. I can move you. Not you. No, not the main window. I want to grab. Yes. The giant head. Okay, so looking at that, everything seems to be fine. It's exactly 7 o'clock, so we can begin too. All right, so I'm gonna close you. I'll leave you open in the background. We can come take a look at where we are. All right, so another day. I've decided to try a slightly different camera angle this time, just to make it look a little bit, I don't know, make it look a little bit better, hopefully. Let me know how you like it or don't like it, or if I should experiment with any other camera angles too. One thing that I was seeing from some other streamers is potentially like a farther away angle, so I don't look so zoomed in, which I can't do right now, but hopefully in maybe a week or two, I'll have the room to be able to do something like that, which will be pretty fun and awesome. But that's in the future. So we're continuing the Department Lookup side, which I realized that's the name that I probably should have called it. So fine, learning Rust, chapter 8. Oh, I did call it Department Lookup. Never mind. I like that. Not cargo, code dot cargo run. It's the fun thing about doing this first thing in the morning right after I wake up. Okay, this is always really feeling weird. RLS starting, RLS not installed. Last time I just closed it and it says it errored out. So this time, sure, go ahead, install. Okay, so with that, let's take a look at what we got in here. Basically, using hash map and vectors, create a text interface to allow a user to add employees' names to a department in a company. For example, add Sally to engineering, or add Amir to sales. Then let the user retrieve a list of all people in a department, or all people in the company by department, sorted alphabetically. Right, like this. So the first thing that we're going to work on is the add, I bet. which is like, okay, we want to be able to, well, probably actually we just want to be able to get the things from the command line, so people can say what they want. So I'm thinking that we go and remind ourselves how we actually grab something from the command line. Keep on looking over there to look at the camera, but it's up there. So let's see. Command line input rest. I don't think I want arguments. And that's interesting. So there's a full crate that I could use. Clap RS, a full-featured fast command line. Open that in the side. That's a command line argument parser. Argument. Did I put? Yeah, no. I just want the input. Aeveris, you could go all out and create a parser using enum or something similar for the input. Ooh, okay. So I think someone once told me about enum. I can't remember who it was, or maybe I just read it on Reddit. So let's take a look at rest enum. Rest parser combinator framework. Okay, so it parses through text. I mean, that's kind of what we end up wanting it to do. So that's from hex, is hex digit. Well, that's that's a hexadecimal color parser. We don't care about that. Nom works great, but it takes some time to get used to. Yeah, I figure like if I want to do something real, then it is definitely going to take a lot longer, because I haven't written anything real yet. It's more of these little things to get me used to the language itself. Okay, so text format parsers. While Nom was made for binary format at first, it soon grew to work just as well with text formats. Like CSV. Oh, so it sounds like this programming language, streaming, parser, combinators. Like if I really wanted to make it actually work with text, I would want to use some kind of Markov chain system. But that is going to be way more complex attempting to do that. Here's a bunch of parsers already written for them. That actually might be interesting too. What was full-featured fast command line argument parser? But that's not what I want. Yeah, that's just provided at runtime. I'm probably not going to use nom at this point in time. Okay, so what I want Rust CLI interactive. Well, somebody asked on the forums, what is the best way to write a CLI app and a Rust? And it's solved, apparently. Oh, clap is my favorite library for apps. Let's see. Well, we just looked at that. That was only for arguments. Nom is definitely overkill for this. What exactly are you looking for? Oh, so what I am doing is, uh, we're going to be basically getting commands like this, and I'm okay if these are like the limitations of what we can do. Is it asks for input and we say uh, add like Sally to sales, add Sally to engineering, um, add Sally to C-suite, or I don't know, like so name department, and then we just pick out add is the keyword that we care about, the name, and the department. And I'm also okay with us saying like, look, if it's not exactly in this format, it's just going to tell the user you didn't do it right. So I need it sounds like the first things, like for example, would be get the user input as a string, which might really be first, which was ask the user for input. Get the command, get the user command. Then we want to sort of extract the command. So extract parts of the command. And then we sort of decide which one we're going to do, which is probably going to be either a match or some other types of, like an if statement, where we're going to say, okay, if we've got an add and we've got these other things, all right, now we can now hand this all over there and do that. Otherwise, tell the person to try again. But so this is like the first part of that, which is let's ask for input. Oh, interesting. Somebody said like, hey, n curses in C is nice. We don't have that. It doesn't sound like anybody is saying we have that. Not sure that this Sevdu is solved, but did anybody... I don't see anybody having their answer like accepted as the solved thing. I guess we could look through crates to see if there's anything that makes it easy for this. Okay, so this is there's a n curses crate that wraps around the TUI library. And I'm guessing it's supposed to be very similar to curses for C. Current basic input and attributes examples. Okay, use standard care. N curses everything. Okay, so function may init screen. So I'm not super happy with their example using this because now I can't, it's gonna be harder for me to tell what is default and what is from n curses. Okay, so init screen raw, allow for extended keyboard. Okay, so that's interesting. Prompt for a character, print W, enter a character, wait for input. Let ch equals get character. Oh, so this is gonna get the character as they type it. Okay, so if the key is, if character is EF1, is that brought in by the curses? Enable attributes and output message. Atron, a bold blink. Print WF1. W pressed. I mean, this is interesting. Refresh, showing the previous message. Wait for one more character before exiting. Get character end window. I kind of wanna try it. Okay, so if I have, where is there cargo.toml? So they're using dependencies. Oh wait, it's theirs. I can't. I did not mean to open Rhythmbox. Okay, so end curses. We'll throw this into our cargo.toml, and let's just play around and see what happens if we see how it looks. So okay. In the compile library, we'll go into the target directory. Note that you must to have the ncurses library installed and linkable for ncurses rs to work. Is this in here? Okay. I might after this see if I can do a pull request to fix that, unless somebody already has done that. On Linux, this should be trivial. On OS X, use Homebrew, which is also trivial. Okay, so let's come back and take a look at this. So we want to use external crate ncurses. Is it extern crate ncurses or just crate ncurses? I think it's extern crate ncurses. So extern crate ncurses. If it's just about parsing user input, I tried splitting the input a white space first. That's probably sufficient for your use case. If you want to create a terminal UI, cursive is a more rusty wrapper around ncurses. Ooh, cursive. It's so easy to go down so many different rabbit holes with this because, I mean, it's fun too. Okay, so cursive Rust. You're probably right that I probably shouldn't do this one for this example and then just put these, like star these and come back to them. So that we can move on and actually get through the book instead of keep on going down rabbit holes. Interesting. So extern creates cursive, use cursive. Use dialog text view. Okay. So creates a cursive root required for every application. Creates a dialog with a single quit button. This might be interesting to play around with. Then starts the event loop. So it's going to loop through, and then every single time we're going to do stuff. And in that case, we're getting this. Lots of interesting ideas there. So I might play around with this also as well. I'm gonna star that. Yeah, let's just go get the, what is it? Standard IO input. This is Google, so of course it's remembered that I've been looking for Rust things recently. Okay, so this is, oh, that's files. Standard input and output, so use standard IO. Standard in.readline input. I don't know what that question mark is. Note that you cannot use the question mark operator in functions that do not return a result. Main, which, didn't they just change that? It doesn't main now return a result? Instead, you can call unwrap or match on the return value to catch any possible errors. I want to look at that operator. Where are you? Okay. Error propagation returns early when error is encountered, unwraps otherwise, similar to try macro. Ooh, okay. So you put that at the end and it just crashes the program essentially when when you want it to. Yeah, because I think what we did last time when I did it was we had like the dot expects or dot oh, I can't remember the basically we took a look at what the exception was and we panicked when there was no input. Okay, so let's just do this then. We will not go down a major rabbit hole for this exercise. Instead, we'll ask for the user input. So we're going to use standard IO. So we'll use standard IO. And now we'll be able to say, okay, interesting, look at this. It has main as returning the IO result. And down here it says you cannot I feel like they're really close because of that big update. It doesn't necessarily crash. If there's an error, it gets returned as the function result so that the caller can handle it. Otherwise, it unwraps the value. But if it's main, the caller is the terminal itself. I'm actually curious now of what that is. So I'm gonna do this. I'm gonna basically make main return this IO result. Is this a tuple? So we're going to turn in IO results. Yeah, in case of the main program probably gets terminated. That's what I was thinking. Parentheses like that. Now, of course, it's saying, hey, you're not actually doing that. Don't tell us that yet. Hold on, give me a second. So we're going to create a mutable string so we can add things into it. Or rather, so we can hand input to it so it can just put that in there. So brand new stuff. Let's try this out. IO standard in read line. Okay, so we're going to say IO standard. Oh, it's nice. This is, hey, I don't need you open. Standard in read line. And then it's the buffer, right? And I think it's going to be the, is it mute? Oh, it's the mute. Yes. So we hand it mutable, which means we do need to have in here, we need the string. So let mute user input, or maybe we'll just put the command. Or raw input, how about that? So raw input equals string new. And in here, we'll put in our raw input, question mark, semicolon. Expected enum standard result found. Okay, did I not do that correctly? IO standard in readline mute input. This question mark on here. Now, where does OK come from? Or maybe is OK basically a result from that? Okay. Okay, let's try OK. So, OK, standard features since, oh. Oh, well, that's not telling me much. This function takes one parameter, so an empty. Okay, is a variant of result. Oh, so that's how this is. So we're just basically saying result, and we're passing it just basically nothing. Interesting. So that's another type of result. Okay, so we have our raw input now. Now, maybe what we can do is verify that we get this raw input. So part of this like get user command is going to be parsing through this, which will probably split on the white space. Let's first print line and actually see what this is. So this raw input. Let's come into here. We're going to do a cargo run. Is this size big enough? Oh, I forgot we have to like tell it what we want to put in. So it's hello world. Perfect. So hello world. So one thing we forgot to do, which was, for me it is perfect. So print line, and we're going to say, please, or enter your command in the form of, I kind of want it to be like add name, possible commands, or maybe just like enter your command. Enter your command, you're like blah, and we get blah back. Okay, so we have the raw input. So if we were to put something in like add name to department, we would now be able to parse that out. So we can put that into a vector with the, I think we can split and then collect. I think that's how it is. So we can say let parts of the command parts. So that command parts equals, we're gonna do raw input dot split. We're gonna split on the character space dot collect. I think I'm doing that right. Type annotations needed for this. Okay. This is going to be a vector. It's a vector of, oh, I forgot the type annotations for vector. Can I find vector in a scope? It's not, is it just vec? Is it like this? Yeah. Oh, so like underscore, where I just say like, yeah, whatever. whatever this is. Okay, so that gives us the command parts. Now let's print this out to make sure that I've got what I think. I keep on forgetting about the underscore in the type systems. So now we have the command parts. So we'll run this again. So we'll say add Sally to engineering. All right, so we have add Sally to engineering. Oh, and interesting, it caught the new line character. That actually might end up becoming a problem, won't it? Because I'm not going to want that in there. Interesting. So I might need to like remove the last character. However, I am able to get the first command out here. Oh, trim before splitting, right. I remember there is that trim. So if we do dot trim like this, then we can split. Add or pop the last character off, right? Because it's a string that's in a heap, we can change the size. So add Sally to engineering. Perfect. I like this one. It works perfectly for us. Okay, so we have our command is going to be the first thing. So I wonder if it'd be best to use a structure for this, so we can basically say, okay, structure, this is going to be the command, this is going to be person, and this is going to be department. And then we can put that into there. I think I do want to try that. We just need to go look up how to do structures again. So Rust structure. Okay, so this struct person, still not also familiar with the quote, single quote A about what exactly that is. But name, string, age U8. That's a reference to a string, I think. Struct with 2 fields. And then that name. Okay, so person, name, and age. Keep in mind that the command might not always be 4 words long when you design your struct. That's true in a real application. Definitely. And I'm thinking for this one, I'll be able to say like, okay, the first one is always going, like I can check if it's only 2 word, well, if the first one is add, then we need it to be a minimum of 3. Because we need to be add, name, and then department. And what I could do is add the second word, so get add, get the second word, and then the third word is always, like, not the third, the last word in the vector is always going to be the department. And then I can just ignore everything in between there. Get will be interesting. But yes, that's a good point. But okay, so it looks like I can just do struct, create the person, give the type annotation. I'm not, so I've seen this around and I still don't fully understand what that quote A is. I wonder if I can search for that. So Rust type quote A. Can I search for quote A? That's tuple types. shared references. A shared reference type is written ampersand, search for lifetimes or lifetime annotation. Oh, that's what it is? Lifetime annotation. I need to fix the DNS settings on my computer. It's making everything really slow. It's doing whatever the currently it's just doing whatever the ISP that I have has set for me, which is theirs, I believe, and I think they're just parsing everything really slowly. A in this case means that the string must at least live as long as the person. Okay. So Danny Fritz sent a message to me, like, so in the middle of his Pong application that sort of we played around with, he did also say that what he's learned is that if you're using these lifetimes and you're trying to set them, you're probably doing something wrong. I think is what he was saying, because it just, if you work with it and you just do the appropriate giving and receiving and changing ownership, then it just, everything is easier and not as complicated and won't burn you later. So I am not going to use that. Instead, for use standard IO, let's struct. Is it just struct? Thought it was. Yeah, it's struct the name of the thing. I was expecting this to change color. Okay, so struct, this is going to be the command. Oh, well, there you go. And this is going to be any type things. No, I don't need anything here. And I definitely want to has that debug so we can print these things out, which is derive debug. It is square brackets on this one. Derive debug. Like that. What are you upset about? Expected item after attributes. What did I do wrong? You look exactly the same. Okay, I don't know why it yelled at me initially. Okay, so we have our struct command, and then we're gonna put in the key and then the types. So we're gonna have the sort of like, is it gonna be add or like what the basic command in? So like the base command is, and I'm thinking like I don't mind giving ownership to this. So we just make these string, and then it's comma based, right? Yep. Okay, so we're gonna have this base command. We're gonna have person, so we're gonna have name. It's gonna be a string. We have okay, so we're gonna have base command. We're gonna have a name. We're gonna have a department. String. We're also potentially gonna have just employees. But you know what's interesting is that if the base command is get, and then we just check to see if department is set. So what's interesting to me is maybe this might be better if it's an option so it can be none. Because right, yeah, so there's a chance that department can be absolutely none. And there's a chance that name can be none, but the base cannot. The base must also always be set to something, either get or add. Employee, yeah, I don't actually care about this if it's a get. We just do care about, okay, so name. I'm thinking maybe option. And then we need the type. Wrong number of type arguments, found one. Option none or some. So I don't know, maybe it's that underscore again. By the way, if I do too much backseat programming, don't hesitate to call me out. Oh no, that's fine. That's why like I came back to this. I do it too. Okay, so I can't do it on tuple, on item signatures. Right. So with option, it can only take some or it can take none. I need to, in a structure, be able to tell it what, because I want it to be nil, right? Like I want it to be none, potentially, or some, and that's exactly what option is for. Also read the message above the one starting with by the way. Oh wait, isn't it here? Oh, and enum might be more appropriate for this. You could have the different commands as enum variants and put the necessary data in the variants. Oh yeah, I definitely could. And then put that in the structure, right? Because I could create an enum. What do I call this? Maybe like a base as the command, and it's going to be the enum, the base, and this is going to be just like a. I need to go remind myself. Enum rust. Okay, yeah. So it's just sort of setting what this is. And I can then say in here what type it's going to be, right? Yes, with the parentheses. So the base is going to be, oh, okay. So I can do base is going to be add, or it's going to be get, and it can't be anything else. It has to be one of those. So I don't even have to put a type in here because this is the type. It's just add or get. But that's just for base. And then I think here in command, the struct command, the base is going to be type base. Base doesn't implement standard format debug. I can do that. All right, I think this is a good way to go for this. The name is going to be a full out string. But again, it can be null, right? So I'm gonna remove this. I need to derive debug. This is definitely where I can see having, like, throwing this into a library makes everything a lot easier because they're just the different files and it's not going to be this one giant thing. Okay, so we're going to have enum, and this is going to be the name. Enum name. Okay, so the name is going to be the employee, and it can essentially be none, or it could be a name itself. So we'll say This is name string or none. You can put everything in a single enum. Ooh, I want to see that. So our enum command add is name string. So are these I don't think I've seen the brackets before this. Is basically it's saying that add can be either of these, or is it like is it diving in where it's like add name department, remove is name department, list is just a string, list all, quit. Okay, interesting. Add has those fields. So these become fields. That almost feels like an enum to the enum. It feels like very structure-like in it. I want to go look that up in, I'm getting too many of these open now. Where was my, oh, I don't have enums open here, do I? Oh, here it is. I want to find fields in here. Here it is. Okay, listing 6.2. A message enum whose variants each store different amounts of types of values. This enum has 4 variants with different types. So move here is the one that looks like that. It includes an anonymous structure inside of it. Okay, so that's what it is. It's an anonymous structure. That, I actually didn't know we could do that. That seems pretty cool. Defining an enum with variants like the ones in listing 6.2 is similar to defining different types of struct definitions, except the enum doesn't use the struct keyword, and all the variants are grouped together under the message type. The following structs could hold the same data that the preceding enum variants hold. Okay, so that's actually really cool. So let's go back and take a look at this. We could use just an enum instead of a structure. So back to here and do enum command. And so we're gonna have the base command is really gonna be add or get, right? So it's just this. Now they were showing, okay, so it can be, well, I guess we could say like, this could be add, get, because we could then use this command as saying like, okay, this part of the command is an add, this part is a get, and then we can just check to see what it is. So all parts of the command is an add or a get. We have a name. So we have a name, which is type string. We have a department, which is type string. We have employees. We don't care about that. And we have department. So let me make sure, your thing again. So you're thinking add is then this, okay, is then this a structure, this anonymous structure, because if we have add, we have to have name and string in here. So I can definitely see that where add is also an anonymous thing where we have name, string, department, string. Then this comes out like that. Then we have get, So we have get on its own, but then get from department. So what were you thinking? Oh, you're thinking of like instead of using get, it was like list, and list all. So it could be just get, and I could also see get get from department, which is going to be a string like that. Now, could I also do something like this? So we have get and then get department string. Yeah, okay, so we can't use get multiple times here. So get by department. Which in this case, if I'm doing that in there, I might as well just make this. But okay, so now we have this enum, and we're going to create multiple of these for each part of these. So we have a vector of all the parts, and now we go through them and we say, okay, well, the first thing, if it is the word add, we create this and then go in there. So what time is it? 7:49. We've got a few minutes before I've got to get ready for work. Let's sort of see if we can set ourselves up for success on Monday. Okay, so we have here's our vector command parts. We're just printing this out for right now. I'm gonna get rid of that. What I want to do is I want to now loop through the vector, or rather, I want to just see what the first one is. So I can actually put this in here. If I do command parts 0, index 0. I don't think I need to debug, but I'm just going to leave it in there. It's sort of, we'll just do add satellite engineering again. And so it is the string add. Perfect. So now I can say, can I match on a vector? I don't think I can match on a vector, but I can do match on command parts 0. And so I can say like either we're going to get add, and then we're basically going to create this enum. Now if I create it here, it won't this won't like work for me, will it? Because it'll be stuck inside of this block. I would either want to create a mutable like empty version out here of the variable that I can then set in here, or put this inside, like send this vector to a function and have it return a structure of the these enums. I think that might end up being good. Let's just try everything in here. So get the user command parts. We're going to say let base command oh right, I don't have to set it as mutable because the first time that it hits, it'll set it and it'll be the only time. Okay, so add equal, and then we're going to set base command is going to be equal to command. It's going to be the add. I think it's parentheses, right? Expected function found struct variant command add. Did you mean command add? Oh, and then the fields. So not this, like this. Missing fields, department name, and initializer of command. Okay. So we need name. So then the name. I'm wondering also, like, if I do add like this, do I want to validate these or just assume that they exist? So, for example, name. How do I put this in there? Is it name? It's gonna be name colon or name equals. It's gonna be like name and then command parts 1. And then we're gonna also have the department. Yeah, it's not liking this. Expected structure, standard string found. Ooh, okay, no, it is sort of liking it. Okay, and then so the department, we need to pass into the string. So we're going to like convert this into a string with a .toString. And department, we're going to say is going to be whatever the last thing is. So that's going to be the command parts of command parts.length -1 .toString. Okay, expected one of found. Okay, I don't want that. Comma. We haven't exhausted everything yet, but that's fine. So this is just the add. If we're doing an add, we've now stuffed all of these. We've now created our base command here. Which, if we think about it, it's not really the base command, it's the full command, isn't it? Because that structure, the anonymous structure, is making it so the base command is an add, but it also has the data inside of it, which is a little bit weird because initially I was getting used to the idea that enums were not going to store complex data for me. But here it feels like it is. Okay, so we've done add. Let's do get. So get. And this is 56. So it is 7:56. I've got 4 minutes total left. So I think what I want to do is then put in here, which is get can be two things. Having a department or not. Of course, that's gonna be really upset at me because we're not finished here. I guess I can handle the everything case. It's like print yo or hello. And then semicolon. Oh, do I not need, oh wait. Because you didn't do it. Do I have to do something? I do. So like print nothing here yet. Right, it's print line. I reverted back to other languages. All right, so technically those are working. We have the various things that we're doing. So, end of the day, we've got 2 minutes left until the end. Thank you, Aeveris, for all this help. I didn't actually think that we could do this in an enum, but this is, I think, going to make it a lot easier to sort of parse out and sort of figure out what the command is doing, and then actually do that. And I really love that we're able to use an anonymous structure inside of an enum. So I'm looking forward to Monday when we come back to this and finish this up, and then see how it see it actually work. Lasagna Lenart. Really cool to watch someone else learn Rust. You've been struggling with it for some time. Well, welcome to the stream. It is winding down to the end, but we're glad to have you here. I have been doing this stream every single weekday at 7 a.m. Mountain Time, except when crazy things happen, like, I get woken up by a evacuation alarm at 12:30 a.m. Then just decide to sleep in, or sometimes I have to break it off early because work asks me to come in early. But normally I'm here 7 to 8 a.m. Mountain Time. Awesome. I'm glad you're able to hang out for 20 minutes. I have a whole bunch of videos on YouTube that are archived from the beginning of the Rust book all the way through here. And we're at the end of chapter 8. As soon as we finish this one, we're going to be going to chapter 9 next week, which will be super exciting. And I don't think I have anything else really. So if you enjoyed this, you want to get notifications when I go live, follow this channel. You can also follow me on Twitter and YouTube, where sort of announcements go out sometimes right before I'm going to stream. All right, I don't have anything else, so I'm going to get ready for the rest of my day. It's over here now. All right, have a good one, and see you next week.